Hello, dear students. Let's continue our discussion on leftmost derivation, rightmost derivation, and a concept called parse tree. As we see, there is a grammar given over here with 5 productions. Now, notice that actually we have 2 productions for A derives BA, and A derives B. Now, both these productions are basically saying that A derives either BA or B. So, this can be equivalently written using OR operator in one line as follows: A derives BA or B. That's just a shortcut notation so that we save some lines, nothing fancy about that. Similarly, 2 derivations are there for B and we have written them on one line: B derives CB or C. Now, let's say we are asked to derive a string as we see over here, A double B C D. This is the string we are asked to derive. So let's see what is LMD for this. We already saw this in the previous video. We will start with the start symbol and then we will replace A with BA, correct? This B and D remains. Then we will replace this A with single B, correct? And BD remains. And finally, we will replace B with single C, and that's the string that we wanted. Now you watch that in each step we have used the leftmost derivation, where among the 2 non-terminals A and B, we gave preference to the leftmost non-terminal A, which was replaced with its options. Again over here, the leftmost non-terminal A was replaced, and finally B was replaced. Now this was about leftmost derivation. Now the same thing, same procedure of leftmost derivation can be represented in the form of a tree. We call it as a parse tree. Now whatever I am going to draw over here is not different from whatever I have drawn or written in LMD. This is just another way of representing the derivation in the form of a diagram. As the name suggests, this is a tree, isn't it? So this will have root node, and root node will be obviously the start symbol S. Now what did we replace S with? Notice the first step in our derivation was S was replaced with AABD. Then each of these constituents become child nodes. So we add 4 child nodes for this node S. Now notice among these 4 child nodes, this leftmost A and small a and rightmost small d cannot be expanded anymore. In fact, these are leaf nodes because small a and small d do not derive anything. They are terminals, isn't it? That's why possibly they are called as terminals, because they are terminal nodes. They are going to form terminal nodes in our parse tree. Now what we did after this is, among the 2 non-terminals A and B, A was the leftmost non-terminal, correct? So we replaced A with, I think, BA. Yes, BA. Isn't it so? Now you watch, we have A as a leaf node, we have B as a leaf node. If you go depth to order and left to right, depth order and left to right, then we have A as a non-terminal, followed by B as a non-terminal, followed by D as a leaf. Now again we have 2 non-terminals A and B, but the first one which comes from the left hand side over here is A. Now we replace this A with small b. So what we have now got is, we have got A followed by B, followed by B, followed by capital B over here and small d. Finally we replace this B. Observe the last step over here. Finally we replace the B over here with small c. And that's it. Now you can watch from left to right, depth wise order. There is absolutely no capital letter, no non-terminal remaining, and all these terminal nodes, I'll mark them, these are the leaf nodes. All these leaf nodes sequentially from left to right give our string, and indeed our string is A double B C D. We say definition wise, A double B C D is yield of the tree. It is the yield of the tree. The tree continues till we get all the terminal nodes, all the leaf nodes. But one thing you should understand is parse tree is just the another way of representing the leftmost derivation. Nothing fancy about this as such. But many times, diagrams speak much or enough. Instead of writing the steps written over here, step by step, leftmost derivation, we can represent it as a parse tree. Coming to the rightmost derivation now, with the same grammar that we had in the earlier video also, just excuse me if I am repeating the same grammar just to keep consistency with our discussion and so that we don't have to learn new grammars for learning new concepts. Just bear with me. I'll introduce more grammars as we proceed. But this was the grammar given. Now, suppose we are asked to derive the same string that was A double B C D and we use RMD, rightmost derivation, then you know that rightmost derivation will begin with S and the only option for S is as shown. Now, from the rightmost, B is the rightmost non-terminal. So this goes here and we need a single C. You watch that. Before D, we need a single C and B can very well give us C. This option over here, B can give us C, isn't it? So now we are left out with A, C, D. Now, the first non-terminal from the right-hand side again is A. So now A can be replaced with BA, CD. Why did we use BA? Is because we need two B's. Now finally the rightmost non-terminal is A. And now we can replace this A with single B. This option I am talking about here, which I am pointing to, and then CD remains. This is the rightmost derivation. Now the same thing, rightmost derivation, can be shown in the form of parse tree. Just observe the parse tree for the given rightmost derivation will start with root and root has to be the start symbol. The start symbol is S. And listen, S was replaced in the first step over here. S was replaced with AABD. So we add four children, four child nodes representing each of the symbols. Now this leftmost node A is a child node. We can't derive anything from small a and small d becomes a child node. But A and B are the non-terminals and you watch that from the right hand side, B is the first non-terminal. So we replace this B, isn't it? In the second step here, we replaced B with small c. That's what we are exactly showing in our parse tree. Now observe again from the rightmost depth-wise. Depth-wise, A. A is the rightmost non-terminal. So in the next step, A is replaced with this A remains, of course. So I am not drawing it again. So what happens in the next step is that A is getting replaced now, isn't it? A will get replaced with BA. That's what we did. That's what we did in the third step here. A was replaced with this BA. And now from again from the right hand side, we have this A as rightmost non-terminal and we replace this A with single b, small b. Now if you watch the string from left hand side, although this is a rightmost derivation, yield of the tree is always all leaves from left to right. We get A, B, B, C, D. So the yield of the tree is A double B, C, D, which is the desired string. Just do one exercise with me. Just watch this tree which you are watching. This was the parse tree we have drawn for RMD. And just go up and just watch this tree which we had drawn as a parse tree for LMD, isn't it? Watch it, although they are going out of screen. But if you see the topology of this tree or architecture or the sequence of the nodes of this tree, then this tree is exactly same as the tree drawn here. You can watch out that each and every node over here in the above and the below tree are absolutely same. So whether you draw RMD as a parse tree or LMD as a parse tree, you will get one and only one parse tree, whether you are doing RMD or you are doing LMD. I hope that point is very clear. So that is about leftmost derivation, rightmost derivation, parse tree. The choice is ours. Which method will we use to show the reader that how we have derived the string? For instance, if let's say we are given a grammar like this, bracketed s, recall this grammar, this was for parenthesized expressions, and s gives epsilon. And we are asked to derive a string this way. This is a valid string which fits in this grammar. We may not use either LMD or RMD. I mean, stepwise description we may not do. We will directly start with the start symbol and say start symbol gets replaced with bracket S bracket. This is the derivation. This is the production that we have used. Now, this S can be again replaced with bracket S and bracket. We have used the same rule again. And finally, this S can be replaced with epsilon. We have now used the last rule, S derives epsilon. Now you can see that all these nodes which I am encircling are leaf nodes. We can't expand any of these nodes, and there are absolutely no non-terminals pending now. So the yield of this tree from left to right, depth-wise, is two open brackets, then epsilon. Epsilon, you can just ignore it. It is empty, and two close brackets. That's the yield of the tree. Basically, we didn't even write the steps of LMD and RMD. We simply have shown the derivation in the form of parse tree. However you do it, you either use LMD, use RMD, or you use parse tree. But after all, our aim is that whether we can derive the given string using any of these methods. Now, when we return in the next video, I will tell you about ambiguity in the grammar. Some of the grammars that you design, some of the CFGs that you see can be ambiguous. By ambiguous, what I mean is they can be confusing. Ambiguity means confusion. And what confusion is there in such grammars and why it arises, we will see in the next video. Thank you very much.